that again one more time for the recorder. You do not have to copy down all these identities again. You should have them. Just confirm that you have them in your Chapter 7 cheat sheet. Today, our goal is to apply double and half angle identities, double angle identities, and half angle identities. That's our goal. We do want to talk about them just very briefly. These three are all cosine double angles. And people always are confused, why do we have three of them? Well, lucky, I guess. We get to look at the information they give us, and then we get to choose which one of these three would work best with the information they give us. If the rest of the problem's talking about sine, then I might want to throw this one in there. If it's talking about, it might have a sine and a cosine squared in it, then I might want to look at this one. I mean, I'm going to look at what is in the rest of the problem to determine which one of these is going to be more beneficial. But all three of them work to find the double angle. Okay? So the half, or the double angle for tangent, and the half angles for all three of them. Now, the half angle ones all say plus or minus out front of the square root symbol. And so our note that you probably don't have in your notes, and we need to make sure we understand. And this you might want to make sure you add. You must choose the sign appropriate for the quadrant that alpha over 2 is in. So if I want the cosine of 75 degrees, okay, then I'm going to use cosine of 150 over 2, because 150 over 2 is 75, right? So the question is, what quadrant is this angle in? Louder, please.
1.
Quadrant 1. And quadrant 1, cosine is positive, so we're going to have to use the, oops, sorry. I said cosine, so let's move that up. We have to use the positive one that represents cosine in that quadrant. Okay? So whatever this angle here is, whatever this angle is here, not this one. Okay, it says what? It says the quadrant that alpha over 2 is in. So not alpha, but the value of alpha over 2. So in this case, that value was 75 degrees. Okay? If I don't know. What's 210? Half of 210 is 105. Okay. So if we wanted to look at cosine of 105, then we could call that 210 over 2. Okay? I know many of you are thinking, well, can't I call it 60 plus 45? And that's true, you could. But if the directions want you to get familiar with the half angle ones, even though you could maybe add or subtract to get to that angle, then we still want you to use the method it says. The point of the problems isn't to say it's the only way to do it. It's to learn that technique so that when that technique is the only way to do it, you're familiar with it and you will not have trouble. Okay? So make sure you have this in your notes. You can put it right on your cheat sheet and match up with your the rules that I gave you. And Why did they throw this in here? Why can't cosine of our angle equal negative 1? What do you think, Garrett? No, the question was, why can't cosine of our angle equal negative 1? What's it say in the denominator of the tangent half angle identity? What's it say in the denominator of the tangent half angle identity? 1 plus cosine. So if cosine is equal to negative 1, what's 1 plus negative 1? 0. 0. So in other words, they're saying we cannot allow this to be 0, can we? Okay? So what they're saying right here is that cosine of alpha cannot equal negative 1, because if it did, I'd have 1 plus negative 1 in the denominator of this identity, and 1 plus negative 1 would be 0, and the denominator would be undefined. Okay? So we're saying this works every time that cosine is not equal to negative 1. So in other words, we can't throw pi in there, can we? Cosine of pi is negative 1, or cosine of 180 is negative 1. So we cannot throw a 180-degree angle in here. We can't use this half angle identity to find the tangent of 90. Okay? It won't work. All right? Okay. Half angle identity. Pi over 8. We need it to equal pi over 8. So what could I use? What angle divided by 2 equals pi over 8? I guess the directions, does anybody have their book open? What do the directions say to number 6? They say half angle or double angle, or just leave it up to us? Okay, good. So what would I have to divide by 2 to get pi over 8? Pi over 4. Remember, dividing by 2 is the same as multiplying by 1/2. And pi over 4 times 1/2 is equal to pi over 8. And so my alpha in this case would equal pi over 4. Is that an angle we know?
Yeah, 45 degrees.
Yeah, so that makes this a little easier. So we're saying, what's the sine of pi over 4 over 2? And so we go back to our rule for half angle. It's plus or minus square root of 1 minus cosine over 2. 1 minus, did I say 1 minus cosine?
Yeah.
Over 2. Plus or minus. Which one's it going to be? Plus or minus?
Positive, because it's in the first quadrant.
Yeah. Pi over 8 is in quadrant 1, right? Okay. So that's going to be a positive. You don't actually have to show the positive. I'm just doing it to emphasize that we didn't just accidentally leave it positive. We chose to make it positive. Okay? And so alpha is really pi over 4. And so we get 1 minus, what's cosine 45? Square root 2 over 2. Over 2. I'll pause this for a minute, make sure we're all caught up. So So Matt said, let's change this one into 2 over 2. I'm thinking he's saying so that we have the same denominator here. Is that right, Matt? Okay. So that means I have on top 2 minus square root 2. On the bottom I have a common denominator of 2 now, don't I? And that's divided by 2. Well, we said earlier, what's the same as dividing by 2? Multiplying by 1/2. So could I just over here write times 1/2 instead of divide by 2? Okay. I'll pause again so you can think about some more. Okay, let's slow down here. This is outside the square root, but only because I was lazy, right?
Oh, yeah.
Because this divided by 2 is definitely inside the square root sign. Okay? So what do we get now?
2 minus square root
So
2 over
you
4.
get. So.
What do we get?
2 minus square root 2 over 4.
Yeah.
Well, square root
We're just
4.
going to multiply our denominators. Multiply straight across. So we get 2 minus square root 2 over 4. Okay? That's kind of convenient because what's the square root of 4? 2. So on top I get the square root of 2 minus square root 2. And on the bottom I just get,
Isn't that the same thing that we just did up there?
isn't that just the same thing we had up there?
No,
Up here,
because,
before you times it by 1/2.
because the 2 is under the big square root sign, and down there it's not. It's the square root of 2 minus, or 2 minus
This,
square root of 2 over 4.
this fraction bar is separating the square roots from that 2.
And couldn't you separate it and make that a fourth group?
I could.
Is it almost?
Now I have to be careful how I do that. I would have to be really careful how I did that. This here is really saying 2 minus square root 2 to the 1/2. And I can't just distribute my powers like that. I'd have to expand it, which when it's a rational exponent is a lot more complicated. So the answer here would just look like this.
It just seems a little less messy.
Yeah, but it wouldn't be accurate. I agree, it would be less messy to call that the fourth root, but there would be terms being left out that are part of that. Okay? So that's how we would leave that answer. Not real clean, not real nice, but that's how it would be left. Okay? Any questions on that example? Okay, number 8. It says sine theta equals 2/5, and they want to know what the sine of 2 theta and the cosine of 2 theta is. But we have to apply our rules. Okay? And so, if we go back to here, oops, there. The sine of 2 theta is 2 sine theta cosine theta, right? And so this is 2 sine theta cosine theta. And again, some of you did this wrong on the test still. If I call this theta, then the opposite side is 2, the hypotenuse is 5. What is this side? Not 4 this time, is it?
5 minus the square root of 2.
2 squared plus x squared equals 5 squared. Brady says, oh, shucks. Won't let me just pull that circle out of there. Brady said it's the square root of 5 squared minus 2 squared. That's correct also. That's exactly what Megan would get had she worked out what she got. And so that's 25 minus 4 is square root 21. Okay? And so the cosine of theta is going to be square root 21 over 5, isn't it? So this is going to be 2 times 2/5 times square root of 21 over 5. And so that 2 is really over 1, isn't it? And so we go 2 times 2 times square root of 21 on top.
Forward 20.
And on the bottom I have 1 times 5 times 5, or 25. And there's no common factors there. So my answer is 4 square root of 21 over 25. Okay? Now on this one, I can use whichever rule I want. Remember there's 3 of them? And if I didn't have to find the cosine, which I just found, then I would only have sine, wouldn't I, in our problem? They told us sine theta equals 2/5.
So you choose a third.
So I would choose the third one because it's got sine in it, nothing else. So I would choose 1 minus 2 sine squared theta. Now, I had to find the cosine to answer the other question, didn't I? So the reality is any one of these would work. But if they only asked me for the cosine of 2 theta, then this last one would be way less work because I have the sine. I know what sine is. And so, was it 1 minus 2 sine squared theta?
Yeah.
I don't think the sine squared part is confusing.
Well, when it's written like this, that means the same thing as sine theta squared. Okay? And we know what sine theta is,
So it would be 60.
right? It's 2/5, right? And so
It'd be 60.
this would be 1 minus 2 times 2/5 squared. And so this would be 4 25ths. So this would be 1 minus, and 2 times 4 is 8. So I get 8 25ths. What's 1 minus 8 25ths?
Well, you have to put it 25 for 25. You put.
So he's saying let's call this 25 over 25. That's correct. And 25 minus 8 is 17 25ths. Don't give me the decimal value for that. Okay?
And wouldn't it be negative? No. Oh, yeah, I mean,
Honestly, we don't have enough information to determine whether it would be a negative or not. We just would go with the positive on that. If they told us what quadrant it was in, then we would know. If they told it was quadrant 2, then I'd make this a negative. Someone want to look at that number in the homework to make sure they didn't say something like that? If they said it's quadrant 2, then you're right, this would be negative.
it says you can give them information to find sine, cosine.
Okay, it doesn't say anything about theta between 0 and... Yeah, right there. Theta is bigger than 0, less than 90. So they're telling us it's in quadrant 1. Okay? I left this stuff out.
So the tangent would be 2 over 21, and then you'd have to rationalize the denominator for the tangent.
The tangent would be... Well, let's write the rule down. I don't remember it.
It's
2 tangent theta
tangent theta.
over
Over
1.
1 minus tan squared theta. 2 tan theta over 1 minus tan squared theta.
So we have to look back at the triangle. And
Yeah.
We go opposite over adjacent would be 2 over root 21, and we have to rationalize the denominator.
Opposite is 2, yep, 2 over square root of 21. So this on top would be 2 times 2 over square root of 21. And on the bottom, I get 1 minus 2 over square root of 21 squared. So in the bottom one, that squared takes care of it for me.
Oh, but on the top.
On the top one, I'm still going to have to rationalize. So on top, I have 2 over 1 times 2 over square root of 21, so that's 4 over square root of 21. Now, I'm not going to rationalize until I'm done, because sometimes things take care of themselves. I don't want to make extra work for myself. And on the bottom, I have, this is 4, because 2 squared is 4, and square root of 21 squared is 21. So this is 1 minus, so that's 21 over 21 minus 4 over 21. So that's 4 over square root of 21 minus 17 over 21. So that's 4 over square root of 21 times 21 over 17, right? Change dividing to multiply by the reciprocal. And I don't see anything that cancels. So I get on top 84. In the bottom I get 17 square root of 21. And then we have to multiply by square root of 21 over square root of 21. Some people would multiply that bottom by 17 square root of 21. It's only the square root we want to get rid of, and because it's multiplying, that's all I have to multiply by. If it was adding or subtracting, I'd have to use the conjugate, but because it's multiply, I can just multiply by square root of 21. So on top I get 84 square root of 21. And on the bottom, I get whatever 17 times 21 is. 357. 21 has a 3 and a 7 in it. Right? Oh, actually 21. 21 goes into both of those. So we go 4 square root of 21 over 17.
So you have to simplify every time?
Yeah.
That's fine.
Yes, you do want to simplify.
That's too much. I can go my notes.
Yep. So, we want to verify this. Looking at it, the left side certainly looks nice and tidy, and the right side looks more complicated. The reality is, for me, it's easier to work with the left side first. I might then manipulate the right side also, but I want to know, what am I looking at on the left side? Okay? And so, if I look at this, tangent 2 theta, I think we just said that one, right? 2 tan theta over 1 minus tan squared theta. Do we agree with that?
Yes.
Okay. Well, I really didn't know which way I wanted to go with this when I first looked at it. I really didn't. And I started to say, I see that I have, I'm going to try to slow down what my mind did. You know how your mind works really quick, right? And I'm going to try to slow that down and explain to you what I was thinking. Just 1 second. Anyway, what my mind was thinking is I first noticed, hey, I've got a 2, and hey, I've already got a 2 up there on the top. And I was looking at this, and to be honest, I wasn't seeing any connections there. I'm thinking, well, cosine over sine and sine over sine, and they're not looking really good. And so that wasn't connecting for me. Then I looked at this and said, well, I have a tangent on top that I don't have there, and I have a tan squared here that I didn't have there. Okay? So that's where my mind.
Cotangent. Couldn't you take the cotangent because it's 1 over tangent and put it on top? You worked with,
No. I like what you're thinking. He said, this cotangent's really 1 over tangent. Don't copy this down. And he's thinking, well, let's just flip this over, that'll put that on top. And I would agree if this minus tangent wasn't there. But to manipulate factors like that, it has to be in every term. Okay? So mathematically, that's an illegal move. That would give you 5 to 10 in the pen. Maybe not quite that long, but that's a no-no mathematically. Okay? I'm glad you're seeing things and making observations. So if you look at this again, I have a tangent here and an extra tangent here. So what do you think I could do? How could I get an extra tangent on top and on the bottom? Times. Remember, we said, that we can take a fraction or whatever and we can multiply it by 1, right? So if I multiply this whole thing by tan theta over tan theta, is that equal to 1?
Yes.
And so when I do that, what do I get on top?
You get
2 tan theta. And on the bottom, I get cotangent theta tan theta. I have to distribute on the bottom because there's 2 terms. I have to multiply everything. Okay? Might want to watch this, Garrett. Minus tangent theta tangent theta. So I went a little slow here to make sure that you understood. I'm taking this tangent and I'm multiplying each term by tangent. And on the top I multiplied by tangent. And so what's cotangent times tangent? It's 1, right? This one is cosine over sine. This one is sine over cosine. They're reciprocals of each other, so when I multiply them, I get a 1. So on top I have 2 tan theta over, and on the bottom I have a 1 minus. And what's tan theta times tan theta? Tan squared theta. And so that's going to equal to tan theta over 1 minus tan squared theta. Okay? And so I kind of manipulated both sides a little bit. I wanted to do this side so that I could see what I was looking for. Because I got to be honest, I was pretty good at this at one time when I did it a lot in college. I got really good at it. I could take really complicated ones and play with them, and I really enjoyed it. It was a lot of fun for me, and I got good at it. But even though I was really good at it, I can't look at this and say, oh, I know what that is. I don't. I don't see those connections. So you have to work on both sides sometimes. And whatever you see, remember the notes or the tips? I said, whatever you see, do it. And don't be afraid to be wrong, and don't be afraid to take the long way around. Okay? Sometimes it's easier to go way around the swamp than it is to walk straight through it.
What?
And that'd be similar to this.
I walked straight through.
What's the question? Did I have a hand up?
Is that tangent?
Well, we had to verify.
So the word.
Does the left side match the right side?
Sure does.
So we verified.
When it tells us to verify,
Yeah. Yeah, if they tell us to verify, that means it does work. Yeah, no, they won't say verify if possible. They won't make you spend an hour trying to figure one out and then say, it didn't work. Kendra?
I thought you could only change one side.
No, what I can't do is use addition property, subtraction property, multiplication property. I can't do things to both sides, but I can apply identities to this side and apply identities to this side. I just can't like say, well, let's subtract tan theta from both sides. I can't do that. Okay? And I can always multiply by 1. And I can always factor. Okay? I mean, to be honest, when I first looked at this, my first thought was, well, that's the difference of two squares. That's 1 minus tan times 1 plus tan. Well, in this case, I didn't need to use it, but that is the first thing I noticed. And so that's something that you want to start thinking about. And over here, I had a cotan minus tan, so at first I'm thinking, well, that could be similar, but, and so I was trying to think how I would make that into the difference of two squares, multiplying by conjugates or whatever. And then I realized that, hey, it's all the difference is that this side has an extra factor of tangent than that side. And then after that, then I made the connection that this was going to equal 1. That was not the first thing I saw. In fact, that was the last thing I saw.
I don't understand how you can make those connections.
Well, again, remember I've done many, many, many of these, and at one time got really, really good at it. And after you've spent some time doing them, you'll get a lot better at them too. Okay?
You didn't have one of those today?
Well, let's see. No.
So that's probably.
Your assignment was 7 to 19 odds, and then tomorrow is 21 to 39, so it's actually 7 to 39 odds. I will continue and do number 12, which looks a little different, and if you want to follow along, you can. If you don't want to follow along, then you can get to work.
That won't affect our notebook, right?
No, it won't affect your notebook score, if that's what you're asking. It would affect your notes. I would have an extra example. Number 12, I think it said sine x over 2 cosine x over 2 equals
Sign of a
sine x over 2. Okay? And so the first connection I see is that these are both half angle. And it isn't like I looked at it and says, oh, half angle. No, I looked at it for about 40 seconds. And then I said, okay, there's got to be something here I know. And then I said, okay, x over 2 is a half angle. So I can apply the half angle identity to that. At this point, I have no idea where it's going to take me. I literally don't. I do not see the connection all the way to the end yet. All I see is that this is a half angle identity. So I'm going to write it down. Half angle identity. Oops, that's a square root, isn't it? Half angle identity. Let me back up. Square root 1 minus cosine over 2.
So we just assume that
And
the product is
cosine is square root 1 plus cosine over 2. Okay? So let me go back to it. So this is the square root 1 minus cosine x over 2. And this is the square root of 1 plus cosine x over 2. And so this is 1 minus cosine x times 1 plus cosine x over 2. You agree with that? I see the whole connection now, but it took me a long time. All I'm doing is if I had square root of 3 times square root of 2, that would be equal to the square root of 3 times 2, which is 6. Okay? And I had to stop and think about what that would be. My first thought was, oh, my square roots cancel. No, they only cancel if this is exactly the same number. Those are not exactly the same number, so my square roots don't cancel. I just get the square root of the product. So the product of the square roots is equal to the square root of the product, is the rule in words. And the product of the square root of 3 times square root of 2 is equal to the square root of the product of 3 times 2. Okay? So now, on top, I'm going to break this down. I have 1 minus cosine x times 1 plus cosine x. And on the bottom, I have 2 times 2, which is 4. And don't forget, I still have all this in the square root symbol. Well, what is 1 minus cosine x times 1 plus cosine x?
Minus cosine x squared.
1 minus cosine x squared. It's the difference of 2 squares, isn't it? So on top, I have 1 minus cosine squared x over 4. Okay? And now, at this point, again, how long it took me to realize it is not really important, but the fact that I did have to stop and look at this and think, what is that number? And my first thought was, well, how do I square root this perfect square? Because that's what I want to do. And it wasn't working because I can't just square root that. If I had something like this, x plus y squared, and I square root it, I get x plus y. But here I don't have a quantity squared, I have individual terms squared. Yeah?
But the 1 minus cosine x, that equals sine x, or sine squared x.
Now you're getting it. That's exactly what that means. He said 1 minus cosine squared x is equal to sine squared x. It's a Pythagorean identity, isn't it? Now I have a perfect square on top, and I have a perfect square on the bottom. So when I square root sine squared x, what do I get? Sine x. And when I square root 4, I get 2, which is what I started with on that side. Okay? Good. I'm glad you saw that. All right. You know your assignment.